Moving on to our within subjects one-way ANOVA. Essentially, overall, we are just looking here to get this data run. But look, you have three dependent variable columns. Each participant gives me three dependent variables on it. There are we're going to get this data over here. We're going to hit paste. All right. Oh, I pasted in the wrong way. I want to undo that. Paste that in here. All right, so this is the within subjects ANOVA. So we click ANOVA, repeated measures ANOVA. This is the funky. What's my factor? It is coffee intake. I'm going to go ahead and put 10 cups first because I expect that to have the best happiness. 5 cups second. And 1 cup third. All right, then what it wants me to do is make sure I put my cups in the right places. So I put my 3 cups in. You can see it give you the results. Now I'm going to click partial eta squared. There is no partial eta squared for between subjects design. This is the best eta squared you should use for repeated measures one-way ANOVA. You just got to trust me on that one. I'm not going to teach that again, but there's a reason for it, and I can teach it to you one-on-one if you'd like. So, is there a significant difference somewhere among your 3 means? Is the omnibus test significant? Yes. If it's significant, is this due to a violation of assumptions? We don't know yet, but let's go ahead and see how we learn that. The repeated measures Friedman test here is a non-parametric ANOVA test. It's significant. You can see that right here. It just showed up. No, not due to violation of assumptions. Estimate the population effect size for the omnibus test. I'm going to click over here and make sure I get up there. All right. So, let's click that away. Let's pull this over so I can see here. I'm clicking down back to our course website to the code section. I know it's a little hard to see. I'll pull it up just a little bit. So I'm going to click this within subjects, 90% confidence interval within subjects. So all I need is my F, which is 11.20. I need degrees of freedom 1, which is 2, and degrees of freedom 2, which is 14. 2 and 14. I click run. I have to pull this up for us to see the result. And we get our lower and upper limits. Remember, 90% confidence interval of eta squared. So, like an eta squared, a small eta squared is 0.01. Medium is 0.06. Large is 0.14. Both of these are large. So, estimate the population effect size for the overall ANOVA. Large, and that's going to be between 0.24 and 0.73. I don't put a 0 in front of there because the largest eta squared you can get is 1. With the post hoc test, you are going to really get a little frustrated here. Going back to our ANOVA, we can get the post hoc test. No problem. We get a effective coffee intake. But you will see, I'm going to make it a little bigger for us since we no longer need that bottom portion. We do not get the 90%, 95% confidence intervals of Cohen's d. Now to do that, we have to run a bunch of paired samples t-tests. 10 versus 5. 10 versus 1. And 5 versus 1. I'm putting them in that order because I expect 10 to have a greater mean than 5, 10 to have a greater mean than 1, and 5 to have a greater mean than 1. That's what I predicted. And all I really want, so now with these post hoc tests, right, you're like, well, what do I do? This is your t value. This is your p value up here from these post hocs up here, and these are your 95% confidence intervals. So now we're just doing this. We're like, mean one is 10 cup. So do 10c because it's how it is. 5c is my mean too. I'm just saying, what am I comparing? One thing that I didn't do is get a descriptive plot for us just to see the data, which I should have done first, just in general. Oh, what happened there? I'm in the wrong one. Okay, yeah. So I would like my estimated marginal means. I would like that for coffee intake. I'd like my means plot. I left that out. You can see it's the same data as we've been using. All right. So I have to fill this out. 10 versus 5 cup. The T statistic is 3.74. The significance value is 0.017. Yes, that is significant. I'm starring that one. The Cohen's D, I have to go down. Right? Actually, I'm gonna go ahead and hide my means plot so I can just do this table real quick. Right? My Cohen's D for 10 versus 5 is 0.33 to 2.27. 0.33 to 2.27. My Cohen's D is 1.323. You can see where I'm getting all this stuff. Let's round it to the right places. Cohen's D can be larger than 1. All right. 95% confidence interval in words is small because 0.2, 0.5, 0.8 to large. So now I do that again. I'm like, my next one is 10. C versus 1C. My T statistic is 3.53. The p-value, 2 keys associated with that, is 0.023. Significant, I'm going to star that. My Cohen's D value is down here, 1.24, 10 versus 1, 1.24, 7, so 1.25. Alrighty. 95% confidence interval of D is 0.28 to 2.17, making it between small and large. Not bad, it's a discovery, but it could be small, not the end of the world. And then finally we got 5 cup versus 1 cup. We got our T statistic, which is 2.646. Significance value is 0.075, so that is not significant. My Cohen's T value, Cohen's D value is 0.94, 0.94. Oh, hit a button on accident. 95% confidence interval is 0.071, less than small, to 1.76, large. So I'm going to do a less than small to large. They're all positive, so I'm okay with that. If they were negatives, I put negatives in there. That's why I didn't do that this time. Nothing really special to do yet except write up our result. So I'm just going to copy this, paste it in. Paste it in for us. F with, we got to go all the way back up. Let's get everything in there. F with 2 and 14 degrees of freedom. 2, 14 equals 11.20. P-value equals 0.001. Eta squared, which is partial eta squared. I should do it the way I'm doing it right here. I'm going to go ahead and subscript that once I get everything in there. Okay, my eta squared is 0.56. I already have it. No, I don't. My eta squared is 0.62 from over here. It's right there, 0.62. My partial eta squared is 0.62. And my 95 CI is between, I'm just going to copy and paste it because I'm lazy. All right. So now I'm just going to go ahead and make that big for a second here, or not, and give that a subscript. I'm going to subscript the partial. But there we go. I don't think I wrote the headline yet. Give me the headline for this specific result. And knowing the data, we saw it. We could look at the picture. I'm not going to look at it because I know it, and it's just kind of 9 different screens going on with this video. But it's drink 10 cups to be happier than either 5 or 1 cup of coffee a day. That's a really bad description. So I'd say drinking 10 cups makes you happier than drinking either 5 or 1 cups of coffee a day. And I'd rewrite that for y'all. But I am over this problem. We succeeded. You can see all my answers. We got it.